hurtling toward Earth for an epic collision. Today on What If, we're going to simulate 6 different planetary collisions, with each one getting more destructive than the last. And we'll be using the help of Space Sim to break it all down and show you the physics behind these collisions. What would happen to our big blue marble? Is it even possible to survive this much planetary destruction? And who will be crowned the winner of this planetary battle royale? Okay guys, we're here with the Space Sim program. What we're going to be doing is crashing planets into planets, mostly crashing Earth into other planets today. I got the What If research team at my fingertips, so if we come across any science that I don't know, which is pretty much all the science, we'll get the research team to look into it and we'll get you the answers right away. First up, what we want to do is smash Earth into Jupiter. Jupiter, as you know, is the largest planet in our solar system. It's a gas giant, which means it doesn't have a solid surface. So let's see how we crash Earth into a gas giant like Jupiter. First up is Earth versus Jupiter. This massive planet is 317 times bigger than Earth. And as you can see here, Earth doesn't stand a chance. Jupiter would swallow it up whole and barely even notice. But would Earth survive the journey up until the collision? Well, let's break it down and find out. Okay, so what we're looking at is Earth, and Earth is, well, oh, there it goes. It's already, okay, so, all right, well, that's the end of the show. Thanks very much for joining us, everyone. We crashed Earth into Jupiter, and that was it. No, I'm just kidding. We're gonna be doing a lot of this. I'm gonna go over this with you right here. So, first of all, I just wanna see, like, what does this mean to everybody? How far, well, before we say how far away from it is, just take a look at Jupiter there. And if you zoom out a little bit, you can see Earth. Now, I don't know if you can tell from this angle, but Jupiter is 317 times the size of Earth, or not the size particularly, but the mass. And what mass is basically weight. Now, weight is not the right term for it, because weight is how you measure your mass compared to the gravity of Earth, on Earth. This is mass because it's out in space. We're not weighing it on Earth. So Jupiter is 317 Earth masses. And also you can probably tell this, 11 times its diameter. So you could fit 11 Earths across, that's a better angle there. Yeah. So if we were able to replicate that Earth 11 times, we could place it 11 times across the side. Okay, let's hit it. Splash, okay. Oh, nice bubbles. It's like me in the bubble bath there. It's like when I splat myself down into the bath after a long day of doing what ifs. Okay, so bubble baths aside, this is not me dropping into a bubble bath. This is Earth being, well, basically swallowed by Jupiter. And don't forget that on this Earth, this is not just like a depiction of a blue marble. This is actually the Earth with 8 billion people sitting on it. Maybe some of them are sleeping. I know I probably am at this point. What would Jupiter look like as we're coming in? It's not like, this is not like the moon, which is a tiny little satellite of Earth. By the time we get to Jupiter, we're looking at something that's, 317 times our mass, and it's basically taking over the entire sky for, well, let's see, that's Africa. So say the people in North America are facing at this, in this instance, say it's North America that's facing, so I'm in North America. I wake up from my slumber because, well, you know why? Because their magnetic field is 20,000 times stronger than Earth's. So my clocks are going crazy. Anything metal is behaving chaotically. Compasses are spinning wildly. My alarm clock that was supposed to wake me up at 7:15 is non-existent at this point. And then we're heading into this gaseous, not void, but this gaseous expanse of swirling orange and white bands. So Earth's oceans at this point and our atmosphere, because Jupiter's so big and so massive, what mass exerts is gravity. So mass is tugging on Earth. Earth is probably, well, I don't know if we're squeezing out at the center, or if our entire planet is just being pulled so strongly into Jupiter. But our oceans and our atmosphere would be stripped by the tidal forces before we even made contact. So those oceans are off. Like our atmosphere is gone. The oceans have probably beat us to the punch and already entered Jupiter's gas. See, as we're getting closer, what happens. Okay, so the people of North America are waking up in a frantic tizzy right now because all they see is this big white band of gas, and nobody really knows what's happening. No, this hasn't been explained to me, why Earth is crashing into Jupiter. None of us know. We're just, huh? What happened? Keep remembering to turn to the camera there. So anyways, we're just about to be crashing into or swallowed by Jupiter. What's actually gonna happen? Let's push it forward just a little bit more. Oh, we get swallowed. You think you're gonna crash, but it's not a solid surface. It's a gas. It's a gaseous planet. Gaseous. And yeah, look, see what we're hitting there. So you're going through layers of hydrogen and helium, and at the deepest layers, you're getting into liquid metallic hydrogen. Maybe there's a rocky core, maybe there's not. Scientists predict there's probably a rocky core there, but it looks like what's happening there, we've created a hole in the gases. Earth is splashing into the liquid metallic hydrogen, and it's like being swallowed by a whale almost. Like you see going into its gullet, maybe swallowed by a dragon. Oh, and then it just closes up. Bloop. Just goes, bye-bye, Earth. So you're probably thinking, okay, well, this is a massive collision, right? Two planets colliding. So what happens if Earth hits Jupiter head on like this? Well, let's be honest, it's like throwing a grape into a bowling ball made of gas. Is there such thing? Not much happens. There's less than a second of actual contact. You wouldn't see, like you see, you're not seeing the explosion on the surface of Jupiter for very long. It's like Earth plops in, Jupiter almost opens up to receive us, and then plop, bloop, and closes back up. So it's almost like Jupiter doesn't care. The gas seals around the impact site within, that's a couple hours, what we're seeing there. It might leave a little bit of maybe a bruise-like scar on the white band of gas or wherever we enter. But that's gonna fade. It'll fade over a few weeks. The kinetic energy of the impact, it's say 2.6 to 10 to the power of 35 joules. So what is that? Well, that's roughly the total power of energy that the sun radiates over a period of 70 years. So the impact was the energy of the sun over 70 years. And Jupiter doesn't care. Watch this, it's just gonna close right up. Bloop. I like making that sound effect. But what does this mean? Well, this means 4 billion years of evolution is just going to be swallowed by hydrogen and helium gas. Like I said, it might leave a little mark for a couple weeks on that cream-colored spot, a little Jupiter bruise, and then everybody forgets Earth ever existed. You, me, 8 billion current people, several billion people who lived here before us. There's no such thing as dinosaurs. There's no such thing as hibiscus plants. There's no such thing as maple syrup. Dinosaurs have been gone for millions of years anyways, but all of it, all of Earth history, wiped out. Kind of sad. Earth and Mars are headed for an epic collision. Instead of one planet winning this collision, it looks like they both lose. But what happens after might result in an even greater planet. Let's break it down. Okay, so we just watched Earth crash into Mars. It's pretty nuts stuff, and it's kind of plausible. It's almost the sort of stuff that Hollywood movies are made of. Let's break it down for you, but this time what I'm gonna do is, because I found out with the Jupiter one, just me talking, it's not that great. I'm gonna bring somebody else in. So I'm gonna bring in one of our What If researchers and producers, Stu. So Stu's gonna join me on this one. That's him right there. He's a pretty smart guy, and he's going to be running the simulation with us. So, Stu, we already saw it once, but let's see it again. Okay, yeah. So this is Mars. So instead of what we saw before was Earth crashing into Jupiter, now we're going to see Mars crashing into Earth. Is that how I'm going to look at it? Mm-hmm. Okay. So this is from the perspective out in space. So slow down. So, wow. Okay, so, I knew that was going to happen because we already saw it in the preview. But obviously Mars is a little bit smaller than Earth. So what we're looking at here is Mars crashing into Earth. And different from the way Earth crashed into Jupiter, Mars, or maybe similar because Earth was smaller than Jupiter, Mars is smaller than Earth. So is there a chance that Mars crashes into us and we have no idea, or it doesn't even bother us? Probably not, because, comparatively, if Jupiter was 317 Earth masses, well, Mars isn't that far away. Mars is roughly about 10% of Earth's mass, not 0.317% of Earth's mass, or 3.17%. It's the closest size match that we're going to see, right? These two planets are the closest in size of anything in the solar system. So, Stu, how fast is Mars going at this point? Or actually, how far away and how fast are we looking?
We're about, so it says 4 radius Earth, so about 2 Earths or so away at this point. So like 1 Earth, 2 Earths.
2 Earths away, okay. So,
and right now it's currently going about, the negative is just position-wise, it's going about 6.2 kilometers per second.
That's pretty fast.
That's pretty fast.
That's about how fast I drive.
401.
In my Mazda. All right, let it go. And I think what you're going to see is something very different from when Earth hit Jupiter. And mostly because Jupiter is a gas giant. Look at this. Oh, boof, stop it there. You can see Earth is exploding here and Mars is also exploding. So, there's half of Earth gone, and basically Mars is a pancake on the western hemisphere of Earth. It's not looking good. And there's those bubbles again from my bath. Looking good.
Yeah, so what you're seeing here, this is basically Earth's atmosphere. I actually don't know if Mars has an atmosphere.
Mars has a thin atmosphere, about it has like 1% of Earth's pressure. Their atmosphere is mostly carbon dioxide, and I believe, it instantly gets vaporized during the collision, but so I don't know if it gets shot off into space like that.
That's probably what you're seeing, is you're seeing this carbon dioxide, this nitrogen, this hydrogen, oxygen just being shot off from both atmospheres.
And all the red dust of Mars.
Yeah, dust and debris, rocks flying off into space.
That was really cool. That kind of looked like some sort of electrocuted tardigrade in space or something. It's like this jelly. Is Earth and Mars together going to make a jelly, a jelly dessert?
Yeah, boba. Yeah, so this isn't going fast enough to create rings. It is going fast, but it's not going quite fast enough. Where at this point, what's happening here is 2 gravities are fighting in the center, right? Because they're trying to figure out if basically everything's getting shot off, and it's like, do we have the ability to...
Right, and that's energy being released there too, right? So what we're looking at is probably the equivalent of billions of nuclear warheads being set off simultaneously when these 2 cores smash into each other. Tell me, obviously this is part of the Space Sims program, but the bubbles. Tell me more about the bubbles.
The bubbles are just representation of the planet's atmosphere. So if I just click it and then I shoot it off, see, the bubbles are saying like, this is Mars. This is all Mars.
Okay.
Like, this is Mars, obviously. This is all Mars, because Mars is just hitting Earth at such atmosphere that, what you're saying, dust, carbon dioxide, its atmosphere is just being shot off into space, and sometimes it comes back. Like here?
Yeah, I saw some of it was being reabsorbed by the gravity of the...
But then sometimes, like you can see up here, that bubble, it's just gone. Because it just goes off into space. It doesn't have the gravitational pull.
It's kind of sad. So basically this would be billions of years ago, how the moon was created, right?
I was just about to ask you that.
Yeah, no, it actually is. It was another planet about the same size as Mars. It was a protoplanet called Theia, collided with early Earth, and the debris, similar to that, was shot off in those circles. It returned and coalesced and became another rock, not planet, but basically a satellite that orbits Earth. So the moon is the remains of Theia, an early protoplanet that came back together after an Earth collision, and is now what we look at every night before we go to bed.
Should we look
We say good night, moon.
Should we look at a new collision?
Yeah, let's look at a different angle. With an orbital crash, Mars would slowly break apart from Earth's orbit. This would cause Earth to transform into something entirely new and maybe turn Mars into Earth's second moon. What would that look like? Well, I think there's also one called Orbital. So show me what would happen if, I think we sort of start, as we get closer together, the moon's a little bit big to fall into an Earth orbit. It's got gravity of its own that would probably fight against it. But let's see what would happen if we got into a bit of an orbital dance here. So you can see right there, oh yeah, we just grazed the top and there it goes. I didn't even see what continent it might have been.
Yeah, so this is Mars getting pulled into Earth's gravity? What would happen?
Now Mars has a gravity of its own, so it's not likely to just succumb. Ooh, and there's a nasty collision. Now, what I want to know is is this like a comet's tail? And a lot of it is being drawn back to Earth by the gravity. So, and it looks like Mars is heading back to Earth, and just about another collision. Oh my God. And then this whole long tail. It's really cool. It looks like a shillelagh or something like that. This for my Irish friends.
So, yeah, I think what you're seeing here is instead of a head-on collision, what would happen basically if we had two planets just beside each other? And it's what's the first thing they would do? Well, gravity would kick in, and then they'd start to pull, and you can kind of see. Maybe you can explain the science a little bit of this more, but you can start to see Mars is perfectly spherical here, and as we get closer,
and it's got a middle bulge.
You see as it starts to pull in, it starts to bounce, and also Earth is reciprocating that. See how it's kind of
Earth's getting a little. See, it's the battle of the bulge. So it's because of the gravity. The gravity is actually tugging so hard on each other. Each planet's gravity is tugging so hard that it's they cease to be a sphere and they're getting squished into an elliptoid.
And then what you're seeing here is the first collision in where?
Africa. That's North Africa.
So you're on the other side. You're fine, Peter.
Yeah.
Well, actually, you might not be fine in a second.
So we're looking. That was like Casablanca there.
I think now you're dead at this point.
Mars is getting disassembled layer by layer, right? It's like Earth. It's got a crust and a mantle, and then a core. It's got an iron core just like us. So I think what happens is it take two runs at it. Basically, it's taking the crust and the mantle off on the first two runs, and then we've basically. Yeah, see, so that on the right side is Mars, on the far right side. That's what's left of Mars. This is all what's being stripped off. This long tail is all the debris that's being stripped off. And just until you see that glowing core in the middle, that's what we're seeing, all that's left. Because it's solid, rigid and dense. It's made of iron, so it's not going to rip apart the way rock does. And it's going to be the last piece that actually hits Earth. So what happens if you run it fast forward? Does it come back and it's going to smash Earth? Oh no,
I think it's gone outside of the orbit of Earth.
So there's Earth. There's first impact, North Africa. It's not looking good for those people, obviously. It's terrible for Mars. Mars is being torn apart. This is partially due to the Roche limit. So when you get close enough to something exerting that much gravity on you, as you saw when see how they bend, right? Both of us kind of bend in the middle, but Mars more so. Mars has bent from It's no longer a sphere anymore. What's happening is Earth's gravity is tugging on it so much that the material on the surface, the crust and the mantle of Mars, is being stripped. So you don't see it being removed from Mars at this point, but basically it's being tugged right off the surface, and it's going to go tumbling into space. And Earth takes a huge impact. Now, you can see a lot of us, you can see the sunshine on parts of Earth still, and there's still the oceans and the clouds are there, but realistically, an impact like that is going to start earthquakes, volcanoes everywhere on Earth. It looks like we're a big blue marble still, and there's still, some southern places where you can go on vacation, but it's not going to be pleasant for anybody, because what's going to happen is all these volcanoes going off and earthquakes is spewing ash into the air, similar to when the asteroid, the world's biggest asteroid, the universe's big asteroid, hit Earth and killed off the dinosaurs. That's kind of what's happening here. We've sustained a major impact. Everything's going to go ashy. Sunlight's going to be blocked out. We've basically lost our atmosphere there. So although we look like we have survived this, nah, we didn't survive this.
This type of collision can only end in one way: complete and total destruction. Both planets need to be extremely lucky to survive this type of crash.
Stu, show me one where we really don't survive. Take a look at this one. Stu's pulling one up that's 40 kilometers per second. What do you think is going to happen here? First of all, what is it that we're looking at?
Well, I know what happened, so I think you should guess what happened.
Okay, well, tell me. This is a major...
So Mars is heading towards Earth at 40 kilometers per second. Around 10 or less kilometers per second, we get something to what we'd see in the last one, which is like the merging of two. Now, if we quadruple that speed, what do you think will happen?
Okay, so this is like the first one, except we're going 40 kilometers per second.
So we're going 4 times as fast. So you saw how fast that first bulge was?
Okay, here's what I'm going to say. Have you ever pitted olives or cherries?
Yeah.
You have one of those olive pitters?
I don't have. I've done it
So I just recently bought myself an olive pitter because, I got a raise here at work. And I like eating olives and cherries, and I don't like the pit. So what I did, I bought one of these things. You put the spherical fruit in it, and you clamp down on it, and it shoots the pit right out. So what I think is going to happen here, Mars is my cherry pitter. It's going to go directly through Earth, pop the iron core of Earth right out, and we're going to be left with a donut Earth.
Donut Earth? I like that theory a lot. All right, let's see what happens.
In which case I will be eating olives, cherries, and donuts.
Well, at this point, there's no olives left. We're all basically dead. So here's what would happen.
Am I right? Oh, is it going to come out the other side? I love that this is the dark side of the Earth, too. We don't see any sunshine. Oh, everything looks like it's... Oh, is it not? How does it not pop out? It disintegrated. Oh, the 2 iron cores are hitting each other. Mars's iron core was smaller, so it's not making it all the way through or popping Earth's cherry.
But it is surviving.
And so what are we looking at here? So this is on the left side. Oh, we had a sphere. Yeah, it looked like a sphere. So the left sphere is Mars, and the right sphere is Earth.
I wouldn't even say that. I would say both are neither at that point. Because at this point, at this impact, right, everyone's dead at this point. Like the way that it's shot out, you have the core just destroyed, and now they're fighting. Oh, sorry. They're fighting to make sure that they can have that gravity. And so with 40 kilometers per second, they're able to just barely hold together. And that's what you're seeing here is basically like, this isn't the side that got hit, but it's almost certainly what you're talking about before. On fire.
Well, yeah.
Volcanoes.
Oh, volcanoes, destruction. We're already dead anyway, so it wouldn't make a difference.
No olives for you.
Wow. And then it comes out Mars is a larger size than Earth.
Well, I'd say this is just one planet now.
Oh, what we're seeing on the right side is
it's just another. They're as you can see, they're starting to merge. See. Now it's just it's mirth.
Oh,
Mars and Earth.
mirth. So that's an really unfortunate one. So it's a destruction of both planets per se. We're still left with something, but unlike in the case of Jupiter, where one planet didn't feel anything and it survives for eternity, now we've destroyed 2 planets but created a brand new fiery magma secondary planet it's going to take a little while to cool. But, who knows? After millions and millions of years, once it's all cooled off, maybe there's still some dirt on there and we can grow plants, and maybe there's an atmosphere that grows there, and maybe, eventually life forms show up. Maybe it'll be better than what we're living right now. Can't be any worse.
Now for our strangest collision yet, Earth versus Uranus. This ice giant rotates at a 98-degree angle, which was a result of it getting hit by a massive object billions of years ago. Would Earth hitting the planet change its axis once again? And what about the icy exterior? Let's find out.
Ooh, nasty stuff. That's nasty stuff. So that's a collision between Uranus, and that's a proper pronunciation, Uranus, and Earth. Earth and Uranus. Let's take a closer look and break it down with Stu. So Stu.
Hello.
This is, so Uranus, and some people say Uranus. As a joke, I sometimes say Uranus, but it's Uranus. As you can see, Uranus is larger than Earth. Uranus is an ice giant. So it's like a gas giant, except this is made of ice, Uranus. It's ice on the surface for sure, but the interior is it's a hot, dense fluid. It's a supercritical fluid. So it's a mix of water, ammonia, and methane ices. So it's not frozen solid. It's actually kind of slushy. It's compressed under enormous pressure, and that actually prevents it from turning solid. So it's about 14 times the mass of Earth, about maybe 14 and a half, and it's 4 times its diameter. So that's 4 times bigger than Earth is what we'd say. Realistically, we could make copies of that Earth and place 4 of them across the belt of Uranus. And something you don't know about Uranus, or I didn't know for the longest time, is Uranus actually, like Saturn, has rings. There's 13 rings around. There, take a look. This isn't an actual picture, but this is a demonstration of what Uranus probably looks like out there. It's got 13 rings, and we're not going to put them on there for you, but it's got 27 moons compared to our 1 known moon. Other fun Uranus facts. Did you know that Uranus has an actual tilt? It tilts on its axis 98 degrees. So it's really the only planet in the solar system that rotates on its side. If it was going around the sun right now, it would look like it was rolling as a ball around the sun, whereas we are kind of like straight up and down and turning on an axis straight up and down. Uranus is turned like that, and it kind of looks like it's rolling through the vastness of outer space. Kind of like this. Can we see it? Oh yeah, it's kind of see it. You see, so that there's a little bit of shading. Somebody was a real artiste when they got in there, and that's what it looks like. Yeah, Uranus is rotating
Ever so slow.
like a ball in a cat toy spinner. And if you have cats, you know what I mean. Okay, so let's see. Stu, shall we take the rings off? We did, I see. And let's have a look at who's hitting who here.
Earth is hitting Uranus.
And Earth is hitting Uranus. Let's take a look. What is it? Not a slow motion, but sort of a slow approach.
We're going pretty fast. About 5 kilometers per second.
5 kilometers per second. Not bad. That's how fast I ride on my 10-speed. Let's have a look at what happens when Earth hits something that is 4 times its diameter. Now remember earlier, Jupiter just swallowed us. This isn't likely to happen here because Uranus is made of ice. So, I think I
play.
Boof. What? We just got swallowed up by the ice giant. And so you can see that's ice breaking up on the surface of Jupiter. Sorry, that's ice breaking up on the surface of Uranus. Mm-hmm. Am I right, Stu? Am I right?
You are totally right. Would Earth impacting this make Uranus warmer?
Well, my guess is yes, because it's going into what we said was hot interior, and then Earth has a hot interior. So you're basically, like you would add an ice cube to a cup of tea, it would make that cooler. In this case, we're sort of adding a hot pocket into, a glass of ice water. So possibly, not dramatically. Uranus is the coldest planet in the solar system, and right at the moment of impact there, it's probably negative 224 degrees Celsius. So adding what's a good day on Earth, 30 degrees Celsius, adding a temperature like that is not going to change it too much. Now Earth is adding some heat through the kinetic impact. When it hits, that's going to create some heat. But Uranus is so massive that the temperature change, it's going to be marginal.
So this is a timeline at the bottom.
7 hours later?
So in the first, Earth hits
T minus 2 hour?
3 hours in.
So what are we talking about? 2 hours into what? After leaving our orbit?
So we're at 0 seconds. So right now they're about, I'd say 7-8 Earths away. So we're moving at 5 kilometers per second. So it would take about 3 hours to get there.
Okay, but that's just an arbitrary distance. It's not like...
No, we just put that distance.
Okay, you could put that anywhere. You could put us 1 hour away. Phew. Good thing we're not doing this in real time. Stick around, people. Coming up in 3 hours from now, Earth.
Yeah, first couple hours just be talking about olives, and then as you can see, 7 hours in, this is what Neptune's like. It's barely...
No, Uranus?
Uranus, that's right.
You and I are awful at this. We both keep forgetting the names of the planets that we're demonstrating. I remember Earth too. Yeah, I was just gonna say that's the easy one. That little blue one with the green stuff on it.
It's very slowly healing itself.
Okay.
But not even a full Earth day has passed by, to be honest with you.
So pretty quickly. I think probably because it's so cold. What those are is probably like cracked up holes in the ice. Mm-hmm. And this is my guess. It's not scientific whatsoever. But it's also so cold at minus 224 degrees Celsius that any holes or any supercritical fluid that's up at the surface is going to freeze at that temperature. And it's almost like my acne medication. It's sort of like covering the pores and...
to drain it out.
Yeah, and then my face is looking better. It's like Clearasil. It's got a layer of Clearasil on Uranus. But what we should say is that what happened to Uranus? Pretty much nothing. It just absorbed another planet. Kind of like Jupiter. Maybe it's slightly warmer internally, but structurally, as you can see, it's healing thyself. And what we should also mention is that because it's on its axis and on the 98-degree axis, Earth's collision would likely shift that axis a little further, adding a little more chaos to an already oddly oriented planet.
Now, what happens if Earth ends up just grazing the gas giant? Would life be able to survive if the planet is still intact? Would Uranus even notice Earth's impact?
Okay, let's look at another look at this, but instead of hitting it straight on at 5 kilometers per second, let's see what happens if the Earth grazes the top. And how fast are we going to be moving on this one?
We're going to be moving 20 kilometers per second, but we're just going to be hitting the top.
Just hitting the top, okay.
Just a graze. So who's at the bottom here? It's a little bulgy.
It's a little...
It'd be...
Does the Earth really look like that?
It'd probably be Australia.
Ooh, okay. Sorry, mate. See you later.
It's about to get a little cold.
You always thought it was much better being down under, didn't you?
Alright, I'm going to hit play.
That's my horrible... Oh, no! There it goes. Oh, and there goes the hydrogen layer, the cloud layer on top. And, doesn't look like... Oh, and Earth keeps going. So Earth does not stop going, and it's still going at a speed of 18 kilometers per second. So it barely slowed Earth down, 18 kilometers per second. And if you go back and look at, you can see how we graze the top and then Uranus keeps spinning. See how it keeps spinning? Go, 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 and yeah, there we go. So it's still spinning in a 360, is it?
Yeah, it's slightly knocked off its axis.
Yeah, and then you can see all the gas sort of goes down to the bottom. This thing is spinning like a fidget spinner.
But we can kind of see that the gas kind of comes back. See how some.
Oh yeah, because the gravity is just it's got enormous gravity, really.
Exactly. So this
It's
is
14 and a half times Earth's mass. So imagine the gravity on there, just tugging that gas right back.
So this gas is gone.
Okay.
But
well.
this gas, watch it condense. See?
Did you know the gas on Uranus smells like farts?
Yeah.
Yeah, you did, eh?
Yeah.
You must have watched our What If episode.
Imagine looking up into the sky and seeing our moon falling down to Earth. We're talking complete chaos and total destruction. But would the moon break up before it hits Earth? And what kind of lasting destruction would it cause on our home planet?
Well, that's disappointing. The moon is supposed to be our best friend. The moon has been with us for billions of years. You know, we rely on the moon, and it goes and just crashes into us and ruins everything altogether. Let's take a closer look here at the moon. Not happy about this, I gotta say, Stu, that the moon would go ahead and smash into us. I know we are conducting the simulation. It's not the moon's fault, but you know, we love the moon. And yet, here it is, crashing into us and ruining our lives. What happens here? So we're not doing a straight head-on collision. This is a grazing.
This is what we call an orbital collision.
Yeah,
which
more of
would
an
be
orbital.
What would happen with the moon, just because the moon's here.
So it's already in our orbit. So we're guessing. Oh, and see how it's squeezing there. So that's the Roche limit, where the gravity of Earth is tugging on the moon. Now you got to remember that the moon is only 1.2% of Earth's mass. It's a tiny little thing, and we overpower it immensely with our gravity. That's why it's breaking up. This is the smallest collision that we're going to see in this show, size-wise, like small thing versus large thing. But look at that. It's basically like an egg, and it's just being torn apart. So even before it's colliding with us, and that's probably not even a collision there, we're probably still far enough that the tidal forces of the Earth exerted upon the moon are just breaking it up into pieces. So yeah, so the moon starts breaking up into thousands and thousands of pieces. The debris is streaming across Earth's sky, and then the sparks there are basically the debris hitting the atmosphere as meteors, and the meteors are burning up as they enter the atmosphere. Then larger fragments end up coming in, hitting Earth's surface, making craters, some of them making craters hundreds of kilometers wide. Mega tsunamis happen. Here's what, so make it hit. Yikes. Okay. So at that point, there's impact from the debris, large fragments hitting the surface, and a lot of them hitting the ocean. What's going to happen is enormous tsunamis racing across the Earth.
Yeah, I mean, basically even before impact, like right here, because the Earth, like obviously the moon isn't just one object, like there's rocks and stuff on it. At this point is where we'd feel most of what you're describing. And then this actual impact, devastating. Oh, absolutely devastating. Because this would be like when this is the whole Earth, the whole moon crashing into the Earth.
So yeah, but in pieces, right? So it's not like one entire giant rock hitting us, where it's thousands and thousands of fragments, and some of them very large, hitting us. And are we going to survive this? Okay, so let's take another look at it. As the moon's coming in, and it's squeezing into a different shape, and it's breaking up due to the Roche limit, and all its rocks are hitting Earth. Nobody's surviving here. This is the end of human life, at least on the surface. And not just because of the impact, but because of all the ejecta and that's the name of the stuff that gets shot out into space. There's the impact, there's going to be a lot of stuff stirred up, there's dust and debris, and it's going to block out the sun. That's the problem with life on Earth, is that we rely on the sun, and when the sunlight can't get through, nothing grows, we've got nothing to eat, and all humans die. So this is a sad state of affairs when the moon hits us. Now, the bright side of this is that, yeah, everything on the surface dies. There's probably some extremophiles in the oceans that survive. There's probably some plant life that survives. So eventually, life will return on planet Earth, and maybe millions of years, and we won't be around to see it, but life will continue on this planet. And that's more than we can say for any of the other collisions that we're going to see in this show. What is this a long tail that we're looking at here, Stu?
That's pretty cool, right? I feel like, so because it's an orbital hit.
Yeah.
Bam. So keep in mind the moon is going about, how fast are we going? About 5 kilometers per second. And so this is the perfect example of its own gravity and speed versus Earth's gravity. And it's that perfect middle ground where right here, if Earth was bigger or this was going slower, this would immediately come back in. But it's in this perfect middle zone where if we just keep going, it's stuck. And what you're gonna see is right here, this is just gonna get longer and longer and longer because this point is going really fast and is basically out of Earth's orbit, but this is slowing down and is stuck in Earth's orbit. And so what you're getting is these two rock debris just constantly pulling apart. And what's super interesting, a second moon.
What?
That's the cool part. You see this bad?
That's our second moon.
Right there. You see how so there's a chance we could get another moon.
So you're saying that's stuck in an orbit. That's not actually heading back toward Earth again.
If it's because the speed's been very much, but odds are this thing is going to become another orbit as these smack into Earth.
Yikes! It's relentless. It's all smacking into Earth relentlessly.
Because if you remember, look at how thin this thing was, right? There's a little bulge in the middle, but it's very thin, and then suddenly compacting, and then we have ourselves a second moon. But even then, it could have the exact same thing could happen again. You see?
Yeah. Oh yeah. Of course. So there we go. So it's not going to become a moon. It's not in an orbit. We have so much gravity that we're sucking it back in. That's an attack on northern Russia.
Yeah. So maybe there's also a very high possibility it could become rings like Saturn.
Oh, okay. Well, that would be kind of neat, even though we're all dead. But eventually, in millions of years, when humans wake up again on planet Earth, they'll open their eyes in the morning and see rings.
Yeah, see cool, which might even be cooler than the moon. Who knows? We'll never know.
That's pretty cool.
It's time for Earth versus Saturn. You might think that Earth would get totally obliterated after moving through the planet's rings, but that actually isn't the case. However, when it gets close enough to Saturn's planetary core, that's a totally different story. Let's break it down to find out what would happen.
Okay, that one's pretty cool, you gotta admit. Cutting through those rings is pretty awesome, but at the end it doesn't look so great because once again we are swallowed and we disappear, and that's no fun. So let's take another look at Earth v Saturn, Stu. And what we're looking at, Saturn is not the biggest planet, it's the second biggest planet in the solar system, 95 times Earth's mass, about close to 10 times its diameter. Less massive than Jupiter, but still obviously way bigger than Earth. And you can tell it's Earth there because it's got its name above it. I think this is the first time we've seen Earth labeled as Earth. Just in case you forgot who you're dealing with, it's us on Earth. Obviously, the most famous thing about Saturn is not that it's the second largest planet in the solar system, but it's got these funky, cool rings. And we've got ourselves set up so that we don't just hit Saturn from the side, that we get to take a little bit of a trip right through the rings. Now, is this the smartest way to go?
No. It's definitely, you have a huge thing, but something to note with the software is this is a little misleading.
Right, they're not that dense. The rings are not that dense. So each one of those is a piece of ice, sometimes rock, and we're going to be splashing right through it. It's pretty narrow. I think, I don't remember, but I think it's like 1 kilometer or not even 1 kilometer wide.
It's at least on this simulation, it's very tiny.
Well, let's get one of our people to look up.
I'll look that up.
We have many people. We have a lot of people working for us here. So one of our what if research is going to look into that. Okay, so we looked into it, and actually the rings are about 10 meters thick. So when we go crashing through there, it's only about 10 meters. And keep in mind how wide the Earth is. We're splashing through this 10-meter thing, and we're looking at how many hundreds of thousands of kilometers?
280,000.
280,000 kilometers that we're going to travel through the ring. So we're likely going to hit one or two. It's kind of going to be like maybe the X-Wing fighter going into the Death Star, or maybe the Millennium Falcon going through an asteroid field, except way less dangerous, because what we're going to hit is more like, would you say snowballs? Probably say snowballs, right?
Yeah, snowballs, kind of ice.
Giant
particles.
hail.
So oh my gosh, look at that. Look how we went really fast there through 280,000 kilometers. How fast were we going?
Currently, we are going about 11 kilometers per second.
11 kilometers per second. Can we slow that down any?
Yeah, I can just go bit by bit.
Yeah, let's go through. So basically what we're hitting, and keep in mind, as Stu said, it's not this dense. Likely what's happening is that these are incredibly far apart. This is a very cold asteroid field. Basically, and you can see it from this picture, it's made up of dirty snowballs. These are chunks of ice, rock, from the size of a snowball to maybe the size of a small building, like your house. But Earth isn't going to be destroyed by hitting that. It might destroy something on the surface of Earth, if it even made it there. Likely what happens is things break up upon impact as they pass through our atmosphere. So not likely that we're going to sustain much damage here. But it is fun to see, how we just ruined the rings of Saturn.
Yeah.
How rude.
What's going to happen to these rings as Earth?
Well, it's going to disturb the rings, obviously, but some of them will probably fall into Saturn. Saturn's a gas giant, so some of them will be, I think you can see some of them are leaning into Saturn as we go. Some actually more leaning out towards, but as you see, they come back together again because of the gravity of Saturn is pulling them back into the places where they should be. Looks like a couple are escaping there through the north side.
Looks like it's thinner here too.
Saturn's rings are only about 100 million years old. So the thinking is they're just here temporarily.
Yeah.
They're not here to stay. The size of these rings, I mentioned they're 280,000 kilometers wide. What does that mean for you? Like, how big is that in terms of Earth? Well, let's just put it this way. You're driving your car, your Mazda 5, at about 100 kilometers per hour. It's going to take you 116 days to cross those rings. You saw Earth just traversed it in a matter of seconds because, well, we're moving at a lot faster pace. Okay, it's interesting to see it from this far away because this gives you a whole lot more perspective. What is going to happen is, you see the width of those rings? That's 280,000 kilometers of rings that Earth, which is about 12,000 kilometers wide, is going to plop through. Now, we are 12,000 kilometers wide, but the thickness of the rings is really only 10 to 12 meters, which is about the length of a school bus. So we, big guy, gonna be almost sliced in half by this knife, but it's not gonna slice us because it's really not that powerful. We're looking at rocks and ice that are about the size of a snowball, all the way to the size of a bungalow. Not really gonna hurt us that much because a lot of that stuff's gonna burn up upon entry in the atmosphere. If you were to do this on your own without the Earth and you're just going to drive in your Mazda 3 hatchback, going at 100 kilometers an hour, it's going to take you 116 days to get across. But you can see, look how fast we're going. We made it all the way through in like a matter of seconds. And see, I love how we sort of ruined Saturn's rings for a while. It's like, they're so beautiful, and we have nothing like that. So it's kind of like, sorry, Saturn, we're ruining your rings, jerk. And they really are a jerk, because watch how we just get swallowed up by the planet as we thought there was going to be a bit of an impact, and we were going to have, some sort of cause Saturn some sort of pain. No, Saturn just says, welcome. Sorry, you're gone. And then we're gone. We've been absorbed by the gas giant Saturn, and look at its rings. They're all coming back together.
Yeah, it's like it's barely been touched.
Yeah, it's like, did we even exist? Well, we don't exist anymore. We've been swallowed up by the gas giant, and now it just carries on as if nothing much happened.
Okay, now it's time to get a little crazy. We're smashing Earth up against every single planet. Which one will survive?
Okay, this is a bit of a wacky one. So what has happened is Earth is placed in one spot, and every other planet in the solar system has been placed 10 Earth distances from Earth. And we're going to see what happens. Are they going to destroy us, or is the solar system just going to go tumble into chaos? I think what's going to happen is there's going to be a bit of chaos. It's not actually going to have much to do with Earth, to be honest.
Something crazy's happening right now. I've never seen this before.
I thought that was something you wanted.
I've never
seen on screen.
It just exploded.
Is this the Big Bang?
I guess. I've never seen this before. It looks cool though. Sorry about that.
It does look cool.
I'm so flabbergasted.
This is basically like, we thought it might be all other 7 planets combined versus Earth, but looks like what's happening is the mass of the largest massed planet, Jupiter, is going to suck everybody else in. Now, the other 7 planets, they're about 447 times the mass of Earth. So it's Earth v 447 Earths, which I think you know who's going to win that one. And Jupiter alone is almost 3/4 of that. 71% of that mass is Jupiter. So let's watch what happens when we place us all within 10 Earth distances of Earth. Yeah, you think they're all coming to get Earth, don't you? But no. Oh, look, the one with the big mass, with the big gravity. There goes Earth right there. But look, it's sucking everything else in. All going in through its gaseous layers and colliding with, but also exploding Jupiter. And wow, Jupiter exploded. So what would normally happen, I think, would be that, Jupiter would be able to absorb each and every one of these planets individually if they were spaced out a little bit more. Everything's sort of coming at Jupiter at once, and Jupiter's like, But I think if Earth went in, it would be swallowed Earth. If Mars went in, it'd be swallowed Mars. A couple days later, Venus, Uranus, even Saturn. And I think Jupiter would be okay. But I think what we're doing here is we're testing the Sims system and smashing everything into Jupiter all at once, which I think all these iron cores, all these rocky cores, all this solidness is hitting Jupiter all at once and probably putting a strain and some stress on Jupiter's core. So I think what happened in the end is we just destroyed, it looks like we destroyed every planet in the solar system. So it's the energy released by all these successive collisions that is just causing the destruction of every planet in our solar system, including Jupiter. The energy released through these collisions, it's going to rival the luminosity of the sun over millions of years. And, if they were able to stay together, they wouldn't be a star, but they would be this glowing orb that would glow for tens of thousands of years. Consider, look at that. I'm in another galaxy here watching this, and these things are all smashing together, and this is what I can see. Whoa! From millions of light years away, I can see this happening.
One by one, the planets line up, looking to slowly converge with Earth until it's consumed in the ultimate cosmic pileup. What planets will be left? And is there any hope for our pale blue dot?
Okay, this one is a little bit different. We have all the planets, this time spaced out a little further than 10 Earths away, but Earth is right in the middle of everything. It's geocentric, so to speak. So everybody is far away from Earth based on their gravitational pulls. So something like Mars or Mercury will be closer because they have a lower gravity, whereas we pushed Saturn and Jupiter further out because they're higher gravity. And basically we did this so that, you know, everything wouldn't just get sucked toward one planet all at one time. So we tried to make it so that everything's not going to smash in at one time, that maybe Earth will pull things in. And I think what's going to happen here, Stu, is that we are going to see Earth is in the center and Earth is going to be the one that's pulling things in first. So what are we seeing here? So there's Earth right in the middle, and we can see that's Mercury, and that is Mars, and then the pink one, oh, it's a beautiful little Venus.
Yeah.
So my guess is they're placed there because Mercury has the least amount of gravity, so we'll put it closest to Earth so it doesn't get sucked up by one of the other planets first.
Exactly.
So let's hit it and see, okay, how we swallow up Mercury. Oh, and Mars is on its way. Oh, who's going to beat who? First, Mercury, yeah. Next, oh, let it hit. Oh, it's Mars, and that's the end of Earth, basically, right there. Double teamed by two planets, and there's Venus. And that's basically, you know, it's the end of Earth as we know it, but we've just combined 4 planets together. So realistically, we've got this super Earth that's I don't know what the actual number is, but probably like 3 times the gravity as Earth currently has.
Yeah.
The thing about this is Stu's not really ready to go, and whenever we try to do this, the stumbling block is usually Stu. So I'm ready with all my talking points. I know what's happening on the screen, but Stu.
Here's
Anyways.
a simulation of me beating up Peter.
So we've become a bit of a super planet here, but up next are the gas giants, and whoa, stop it right there. This is Neptune first, in the light blue, the sort of off gray. What a nice color that is, by the way. I don't like, on the right is Uranus. I don't really care for that color, but I do like the Neptune. But regardless, Neptune, little lower gravity than Uranus, so it was placed a little bit closer. So it's going to suck up the super planet first. But look out, Neptune, because here comes, ooh, swallowed by Uranus. Okay, and then next, obviously, we've got Saturn bearing down on this super planet. But what's happening is they're both like this, I don't want to call it Earth, but the super Earth is moving away from Saturn, or moving at the same speed as Saturn toward the big, giant, gas giant, Jupiter. Okay, so what's going to happen? Yeah, Jupiter gets to it first. Jupiter eats Saturn's lunch, and guess what's next? They're going to eat Saturn. So at this point, all planets in the solar system have become one. Even the rings of Saturn are gone, and emerging like the phoenix from the flame here is Jupiter, still on fire, but I'm guessing that after a few million years, that heat subsides, stops being on fire, and what you're left with is an ultra planet. Now, I would say this is just a giant Jupiter that's eaten everybody, but Stu, you disagree.
No, I would describe this as a new planet entirely. I don't think anything is left, as you can see from this impact. Jupiter's huge, don't get me wrong, but getting hit by not 1, but 2 planets a lot closer to your size.
Yeah.
Especially at that speed.
Well, it's kind of like what we saw in the first set of collisions where, you know, Jupiter got bombarded by too many iron cores at once and just the whole thing exploded. But here it didn't explode, it stayed as one. So that's why I want to say that, you know, it is the last person standing is Jupiter.
If this were to be anything, it would be Jupiter, if
Yeah.
not something new entirely. And you can see all the dust and debris. There's a little bit of Saturn's ring getting shot off into space.
Wah, wah. Well, congratulations to Jupiter on being the last planet standing. Ultra planet Jupiter. Jultra planet. This was a really cool experiment using space sims. I think this is something that we'll do again. Is there something that you want to see smash into something else up in space? Well, why don't you leave us a message in the comments, and maybe that'll be our next episode. Thanks for joining us.
Every planet in the solar system is hurtling toward Earth for an epic collision. Today on What If, we're going to simulate 6 different planetary collisions, with each one getting more destructive than the last.